All right, guys, so in this video we are going to pick up where we left off with handout 27, and then we're going to move on to 28. So remember, last time we met, we went over the equivalent fraction method, and that's where you take a fraction, you change its denominator to a power of 10, and then you can write it as a decimal. Now, we had also talked about long division, and we had done one example of that. So I'm going to go ahead and try to do a couple more. So number one, we have 3/8. So remember that we're dividing by 8. So 8 goes on the outside. And since 8 doesn't go into 3, I'm going to write this as 3.00. All right, so I bring that decimal up. I know that 8 goes into 33 times. That gives me 24 with a remainder of 6. So I'll pull down a 0. And I've got to keep going until it terminates, meaning I get a remainder of 0, or until I get a pattern. So if I keep going, that's going to be 56 with a remainder of 4. So notice once I get to here, I get 8 times 5 is 40. I get a remainder of 0. So that means I'm done. And it means that 3/8 is the same as 0.375. So that would be a terminating decimal. So for 11 over 40, let's see, I may have to make some room here. I may have to go delete some of these. I'm going to go ahead and squeeze this one in the corner right here. So I'm going to go 40 into 11. And 40 doesn't go into 11, so I'm going to do some zeros here. 40 goes into 110 twice. That would be 80 with a remainder of 30. And I'm going to bring down a 0. So I'm thinking 4 into 30. 4 would go into 37 times. That'd be 28, so that'll be 280. Remainder of 20, bring down a 0. Now 4 goes into 20 exactly 5 times. So 5 times 40 is exactly 200. So this one also terminated. I'm just going to box it right here. So here we have ones that terminated or ended. And then last time we talked about one that repeated. So let me do some more repeating ones. Let me switch colors. So let's try 5/11. Okay, so 11 doesn't go into 5, so I'm going to put some zeros there and bring my decimal up. So 11 goes into 54 times. That's 44 with a remainder of 6. Bring down a 0. 11 goes into 60 5 times. That would be 55 with a remainder of 5. Bring down a 0. So now I'm doing 11 into 50, which feels very familiar. I just did that. So that would be 4 times. That'd be 44 with a remainder of 6. Bring down a 0. And that would be 5. So I begin to see a pattern that 4, 5, 4, 5 is going to repeat. So I'm going to write that. Since there's 2 repeating digits, I want to write the 4 and the 5 and put a bar over both. So the last one I want to do is 3/7. So the sevenths are the ones that go out a long time before they repeat. So I'm going to squeeze this one over here. So 7, make this kind of long, 7 into 3. All right, 7 doesn't go into 3, so we're going to throw some zeros on there. 7 goes into 34 times. That's 28, remainder of 2. Bring down a 0. 7 goes into 22 times. That's 14, remainder of 6. Bring down a 0. 7 goes into 68 times. That's 56. Okay, I need some more zeros. So far, I'm not seeing the same number more than once. So 7 goes into 45 times. That's 35 with a remainder of 5. Bring down the 0. 7 goes into 57 times. That's 49. Remainder of 1, bring down a 0. I hope I'm almost done because I'm out of room. 7 goes into 10 once. And I get a remainder of 3. Now notice I started with a 3 and now I have a 3. So now from here it's going to repeat. So it's going to go back to 4, and it's going to go 4, 2, 8, 5, 7, 1, and it's going to keep repeating. So for the sevenths, it actually goes out 6 places before it repeats. So I want to write all 6 of them down and put a bar over the whole thing. All right, so not the most fun method, but that's how you can go from fraction to decimal, and it's the only way to do it if you have a repeating decimal. right, so let's flip over to the next page. This is 28. I'm not interested in this side, but I do want to look at these. So we're going to start with the first three. This is converting terminating decimals to fractions. So basically I just have to say it, and then that'll change it to a fraction. So if I read number 1, that is 36 hundredths. So that tells me how to write it as a fraction, 36 hundredths, so 36 over 100. And remember here, the number of decimal places will match the number of zeros. So 2 decimal places is 2 zeros. Now I can reduce that one. It looks like the top and bottom are both divisible by 4. And that would get me to 9 over 25. So for number 2, that's tenths, hundredths, thousandths. So that is 36 thousandths. Again, the top and bottom are divisible by 4, and that reduces to 9 over 250. Okay, our last one, we have tenths, hundredths, thousandths, 10 thousandths. So that'll be 18 over 10,000. And you can check, there's 4 zeros here, and there's 4 decimal places here, so those should always match. This one's only divisible by 2, top and bottom. So we get 9 over, let's see, 5,000. All right, so let's talk a little bit about the repeating ones. So we're not going to do problems like number 7. The problem with number 7 is it has a non-repeating digit before the repeating digit. So we're not going to do those. What we're going to do is we're going to look for a pattern. So let's look at number 4. It has 1 repeating digit. Oops, I can't spell today. Okay, so when you see 1 repeating digit, I want you to think 1, 9. Okay, so 0.7 with a bar is going to become 7 over 9. And if you have 2 repeating digits, I want you to think 2 9s. All right, so this would be 54 over 99. Now it looks like that one reduces, so I could divide the top and bottom by 9, and that would give me 6 over 11. Okay, so the last one has 3 repeating digits. So I want you to think 3 9s. So the repeating ones always go over 9s. So that'll be 235 over 999. All right, so just some extra examples over here. If I have 0.02 with a bar over the 2, that's 1 repeating digit, so that becomes 2 over 9. Now, if I didn't have the bar there, if it was just 0.2, that would be 2 tenths. So notice the difference in the denominator when it's repeating or not repeating. So if I have 0.13 with a bar, that's 2 repeating digits, so it goes over 2 9s. If it was 0.13 without a bar, that would be 13 over 100. So you can see they're really close, right, but not quite the same. All right, so that gives you a little bit of a review on going from fractions to decimals and decimals to fractions.